Jai Gurudev and good morning student. Today again we have to summarize electrochemistry. So electrochemistry is that branch of chemistry which convert electrical energy to chemical energy. So this is the first point about the electrochemistry. Second point, what we have to learn, we learn about some two types of cell. One is your electrochemical cell, another one is electrolytic cell. So electrochemical cell के बारे में electrochemical cell, in electrochemical cell what I have learned, this chemical energy of the redox reaction is converted to electrical energy, and in electrolytic cell electricity is run to run a reaction which is not spontaneous. To non-spontaneous reaction, for that we have to do electrolytic cell. So if you have converted that from water you want to get hydrogen and oxygen, we can use the electrolytic cell. But for electrochemical cell, that is the cells used in the batteries, this is your electrochemical cell. Then after that, what we have learned is that your Faraday's first law and Faraday's second law. Now Faraday's first law is that your W bases to Q, and second law is that W bases to E. First law, W equal to ZIT. Second law is actually W by E1 is W2 by E2 is equal to W3 by E3. So this is Faraday's first law, this is Faraday's second law. The first law can be modified W equal to ZIT. Rather, I can modify this one again. So what is Z? This is your equivalent mass into I into T by 96500. Second law, it is W1 by E1, W2 by E2, W3 by E3. So this is first law, this one is second law. After that, we have learned some terms in this chapter. These terms are actually what we have learned your resistance R, then conductivity G. G is the reciprocal of resistance. Then we have learned conductivity, kappa. Kappa is the reciprocal of resistivity. Then we have learned G star, which is your cell constant, which is the ratio by length by area. So all these things we have learned. Then we have learned some definition. For example, kappa is called your specific conductivity, and this kappa is the conductivity of all the ions present in unit volume. So in this one, you remember this one you have to take unit volume, 1 centimeter, 1 centimeter, 1 centimeter. This is what is called specific conductivity. Then we have learned molar conductivity. Molar conductivity lambda m we have given. So molar conductivity lambda m. This is the conductivity of 1 mole of solution placed between two electrodes 1 centimeter apart. 1 centimeter apart. If two electrodes are 1 centimeter apart, then what will be there? conductivity. And remember that within 1 centimeter per electrode we have to kept 1 mole of the electrolyte. So from molar conductivity relates to specific conductivity kappa into 1000 by C. This is molar conductivity. After molar conductivity we have defined one law. This is the Colruyt's law. Colruyt's law, which tells you that if I want to, Colruyt's law, remember Colruyt's law is used to get the conductivity of strong electrolyte. So strong electrolyte conductivity, for example, if I consider CaCl2. So conductivity of a limiting molar conductivity of a strong electrolyte is equal to the sum of the ionic molar conductivities of individual cation and anion. So in that one, how many calcium are there? 1 calcium. So if you multiply that one with 1, 2 chlorine is there. So if you multiply this one with 2. So what is the limiting molar conductivity of an electrolyte is equal to the sum. Plus means is equal to the sum of the contributions of ionic conductivities of individual cation and anion, each multiplied by a number which is present in the stoichiometric ratio, or which is present in one formula unit of the electrolyte. So what these things we have learned about the Colruyt's law, and by applying Colruyt's law we have to do most of the things. Now regarding your molar conductivity, we have to learn the variation of molar conductivity for weak and strong electrolyte. So another point that we have learned in this unit, the variation of molar conductivity for strong and weak electrolyte. So if you have plot, this is under root C concentration, this is 0.2, 0.4, 0.6, and this one is molar conductivity. For your weak electrolyte, the molar conductivity increases sharply, but it is not going to intersect the y-axis. So this is your weak electrolyte CH3COOH, and this is your strong electrolyte KCl. So these two lines become parallel, but if you have extra plot this one, strong electrolyte, this one coincide with that y-axis. So this point is called your limiting molar conductivity, lambda and naught, or sometimes you can lambda infinity, all these things you can put. So what you have learned from that one, that the limiting molar conductivity for a weak electrolyte you cannot calculate, but limiting molar conductivity of strong electrolyte can be calculated. Now here we have to learn the applications of Colruyt's law. Application of Colruyt's law. The first one is that from Colruyt's law we can find limiting molar conductivity of weak electrolyte. If I take the weak electrolyte, organic acids are weak electrolyte, so we have taken the weak electrolyte CH3COOH. So this one is equal to, now this weak electrolyte conductivity, this one actually equal to ionic molar conductivity of CH3COO negative and ionic molar conductivity of H positive. So if somehow we get this one, we can easily calculate this one. Now what we are doing, that to know what will be the, how we are going to get the molar conductivity of weak electrolyte, Now you see, this weak electrolyte can be made combination of three strong electrolyte. CH3COO. You put one Na, that becomes a strong electrolyte. From that H positive part Cl. Now if I write this one, these two are present in here. NaCl is not present here, and then if I take another electrolyte NaCl, you can easily find out the molar conductivity of this strong electrolyte. So what we have to write? You have to just, student, you think this one. CH3COOH is equal to CH3COONA plus HCl minus NaCl. So this Na cut, this Cl cut. So what you have to write there? Lambda. You have to write lambda there. You have to write lambda. So this, from that we can calculate the strong electrolyte. This is actually capital lambda you have to write for your electrolyte. For individual cation and ion, you have to write the small lambda. So student, we have learned the application of Colorad's law. There are two more applications of Colorad's law. This is the first one. Second one is that degree of dissociation alpha is equal to molar conductivity, limiting molar conductivity by molar conductivity. Another use that you have to find Kc. Kc is equal to C alpha square 1 minus alpha. So from that Colorad's law, applying Colorad's law, we can find these things. After that, student, in this chapter we have read about some cell and cell representation. Then we go for your non-stication. So after that we have read about electrochemical cell. In this one, in this cell, what we have learned, this is connected by salt bridge. So we have to learn the function of salt bridge. This is an electrode, this is another electrode. So this is the cell that we have learned. In this cell, the student, one more point we have learned, lone, left oxidation, anode negative. So here one thing you have to learn, that E naught of cell is equal to E naught of right minus E naught of left. So here we have taken zinc sulfate, here we have taken copper sulfate, so that can be right. E naught of right means copper 1, so Cu 2 positive public Ce, E naught of Zn positive Zn. Actually we have taken the reduction potential in both the cases, otherwise both are going to be added up. If the one is oxidation, another is reduction. So these things also we have to remember. Now this is at standard state. At 298 Kelvin, we have taken 1 molar of this one, we have taken 1 molar of this one. Now, if I don't taken that 1 molar, instead of taking 1 molar, I have taken the 2 molar or 1.5 molar, 1.3 molar. The 1 molar cannot be maintained always. In that case, we have to use another equation called non-stication. Non-stication tells you what? That you can find the EMF of the cell other than your cell having 1 molar solution, unit solution. So E of cell is equal to E naught of cell minus 0.059 by n log whatever ion will be the right hand side ion by left hand side ion. So like that you can write E of cell equal to E naught of cell with this and that. This is what is called non-stickation. From the non-stickation we have learned two more relationship. One is your Kc. We can find out the Kc and all these things. And another one is value of del G. Actually del R G standard equal to minus NF E naught of cell. So we can calculate out, and again we are getting del R G standard is equal to 2.303 RT log Kc. So these are the formulas that we have derived from non-stickation. Then we have learned about the batteries. So for batteries, actually student, what we have learned about the two types of batteries. One is primary batteries, which cannot be recharged. Another one is secondary batteries. Primary batteries, we have read about dry cell. In dry cell we have get that there is a zinc is your anode, and in dry cell carbon is your cathode. So dry cell we are using MnO2, ZnCl2, NH4Cl as electrolyte. In dry cell overall reaction we are getting some ions are involved. That is why in dry cell the voltage is decreasing with the passage of time. Now after dry cell what we have learned? After dry cell we have learned about your mercury cell, which we use as hearing aids in watches, having the voltage of 1.35 volt around. Then one of the most important cell what we have learned, this is a lead storage battery. In the lead storage battery, your anode is your lead, cathode is lead dioxide, then electrolyte is 38% sulfuric acid. Now one of the most interesting point about this reaction is that one number that I have told you to learn. This is your 11222. These are the coefficient in the overall reaction. 1 means 1 lead, 1 lead dioxide, 2 sulfuric acid convert 2 PbSO4 plus 2 water. About your lead storage battery, what I have told, when the reaction goes from reactant to product, at that time is the discharging of the cell, means inverter is working. There is no current, inverter is working. But when the current is available, from the product the reactants are forming. This is called charging. Now in this kind of batteries, what we are getting, that in this kind of batteries we have to add water to time to time. Why we require to add water to time? Because during electrolysis lots of water are lost. After that, what a nickel cadmium cell, that one was the important cell you will learn. Another important cell we have learned about the fuel cell. Fuel cell are those cells from the combustion of fuel we are going to get the electrical energy. Now in the space research work we are using the hydrogen oxygen fuel cell. In that hydrogen oxygen fuel cell, what we are getting, that the hydrogen and oxygen from two cylinders are bubbled through an electrolytic solution of aqueous NaOH, where the hydrogen and oxygen react together forming water and energy. The water, that is pure form, can be consumed by the astronaut and for drinking purpose. Another one, the energy that is generated from the cell can be used for run the rocket. Now another point student, what you have learned, that the fuel cell is important because it is pollution free. Fuel cell is important because its efficiency is 70%, and fuel cell never dead until we are supplying the reactants. Hydrogen oxygen supply is there, aqueous NaOH is there. After the fuel cell, student, I have learned about last topic is your corrosion. Corrosion, what we have learned, the eating away of metal surface due to environmental condition or in the presence of water, acid, etc. Now what we have more interesting point we have learned that the corrosion of iron is called rusting. Rusting having formula Fe2O3x water. So it is hydrated ferric oxide, or you can write hydrated iron 3 oxide. Now we have learned about the phenomenon of rusting, mechanism of rusting. In that one, what we are getting, the rusting takes place due to the formation of carbonic acid, the reaction of water with the carbon dioxide. Now if we coat a basic layer over that iron nails, the rusting can be prevented because acid and base become neutral. Another point student you will learn that the saline water increases the process of rusting because in saline water what happens, there is ions are there and ions makes the process of rusting faster. Then student, we have to learn some prevention of rusting. Prevention of rusting, we have learned that you have given the zinc coating over the iron articles, painting, greasing, then some sacrificial electrodes such as magnesium, all these things. So this is what we have in unit 3. Another 2 or 3 points student I want to discuss. These are your from the first law in what we have learned, the Faraday's first law can be used for gaseous product. So Faraday's first law can be used V equal to IT into VE by 96500. This is called equivalent volume. The volume of the gas by 96500, and this is the volume evolved at STP. So this is the first law when the gaseous substance comes out of the electrode. This is Faraday's first law. Another point, if there is a thick coating take place, so if the area of the sheet A into B and thickness of the coat is C, then volume become A into B into C, and if density is equal to D, so therefore that become A into B into C into D. The volume into density is mass, and that mass is equal to again your ZIT. So from that also you can find out thickness. Sometimes student, it is radius is given. If radius is given, from radius we can find out the volume. Volume is what is the formula? 4 by 3 pi r cube. And if density is known, 4 by 3 pi r cube into density, what is called the volume, density equal mass per unit volume. Density equal to mass by volume, and mass equal to volume into density. So from that mass also we can calculate. So this is what we have from this very important chapter, electrochemistry. All of you prepare the chapter and get 5 marks in the exam. Thank you.